Imagine the thrill of watching a massive rocket poised to launch a cutting-edge satellite into the stars, only for a tiny valve to throw everything off track again. That's the frustrating reality behind the latest setback for the ViaSat-3 F2 mission, where technical hiccups are delaying humanity's reach for the skies. But here's where it gets controversial. Is this just a minor glitch? Or a symptom of deeper vulnerabilities in our space infrastructure that could reshape how we view rocket reliability? Space enthusiasts and industry watchers, buckle up. This story of perseverance in the face of adversity might just reveal more about the challenges of modern rocketry than you think. United Launch Alliance, ULA, has once again hit the pause button on the launch of the ViaSat-3 F2 satellite, marking the second consecutive night of scrubs due to an unrelenting problem with the Atlas V booster's liquid oxygen vent valve. Originally slated for liftoff from Pad 41 at Cape Canaveral Space Force Station at 10:16 p.m. EST, 03:16 UTC on Thursday, the mission was postponed, with a fresh launch date still pending announcement as of 9:10 p.m. EST, 02:10 UTC on November 6. To put this into perspective for beginners, let's break down what happened. The Atlas V rocket relies on liquid oxygen as a key component of its fuel system, and the vent valve plays a crucial role in managing pressure and ensuring everything stays safe and stable. During the final checks before launch last Wednesday night, this valve didn't perform as expected, leading launch director James Whalen to call off the first attempt. Fast forward to Thursday, and despite efforts to rectify the issue, the problem resurfaced. Just over an hour before the launch window was set to open, ULA decided to stand down once more. In their official statement, the company explained the launch of a United Launch Alliance Atlas V carrying the ViaSat-3 F2 mission for Viasat is scrubbed for tonight's launch attempt due to a reoccurrence of the issue with the Atlas V booster liquid oxygen tank vent valve. The team will evaluate the hardware, and we will release a new launch date when available. For those new to this world, the countdown process is like a meticulously choreographed dance. At ULA's Advanced Spaceflight Operations Center, ASOC, located about 4 miles south of the launch pad, controllers kicked off the sequence shortly before 3 p.m. Eastern Time. They progressed to filling the Centaur upper stage's liquid oxygen tank to full capacity and were in the midst of loading the booster when the decision to scrub came around 9 p.m. Eastern Time. It's a reminder of how even small mechanical failures can halt operations, underscoring the precision required in aerospace engineering. Think of it as a car engine refusing to start because of a faulty spark plug. And this is the part most people miss. Weather played its own supporting role in the drama. Thursday afternoon brought overcast skies to Cape Canaveral, complete with heavy clouds and intermittent rain showers. Launch Weather Officer Brian Belson from the 45th Weather Squadron at the Space Force's Space Launch Delta 45 assessed the conditions as a 50-50 chance of clearing the launch criteria, citing those layered clouds and precipitation as the main obstacles. Weather integration is vital in space launches, as it can affect visibility, safety, and even the rocket's trajectory. It's not just about clear skies. It's about minimizing risks from unpredictable elements like lightning or gusty winds. Now, let's zoom in on the star of the show, the ViaSat-3 F2 satellite itself. Housed within the Atlas V's expansive 5.4-meter diameter payload fairing, this 6-metric-ton spacecraft is a marvel of modern technology, crafted by Boeing. Once launched, the rocket's hydrogen-powered Centaur upper stage will ignite 3 separate burns, expending nearly all its fuel in a strategy known as minimum residual shutdown. This technique maximizes the satellite's speed upon deployment, occurring about 3.5 hours into the flight, and aims to boost its operational lifespan by placing it into a geostationary transfer orbit, a high-altitude path that keeps the satellite in sync with Earth's rotation for optimal coverage. For context, imagine geostationary orbits as a cosmic parking spot, where satellites hover over a fixed point on Earth, enabling continuous communication. This mission represents the second in the ViaSat-3 lineup, following the 2023 debut of ViaSat-3 F2 aboard a SpaceX Falcon Heavy. However, that predecessor faced its own trials, an antenna malfunction that not only pushed back service activation, but also limited its bandwidth. It's a prime example of how even post-launch issues can ripple through a satellite's performance, affecting everything from data speeds to service reliability. Viasat's team is optimistic about the newcomer, touting it as a game-changer with K-band network enhancements that will inject over 1 terabit per second, TBPS, of additional capacity into their network across the Americas. After rigorous on-orbit testing at its designated slot, that's 79 degrees west longitude, the satellite is anticipated to go live in early 2026. This expansion could democratize high-speed internet, especially in underserved regions. But it also raises questions about equitable access. Why prioritize the Americas over global needs? Speaking of controversy, these repeated scrubs aren't isolated incidents. They echo broader debates in the space industry about rocket dependability. Critics argue that aging technologies like the Atlas V might be pushing their limits, potentially favoring more frequent scrubs over rushed launches, while advocates see it as prudent caution. And here's a counterpoint that might surprise you. Some experts suggest these delays could actually spur innovation, forcing companies to invest in more resilient components. Is this valve issue a red flag for ULA's future, or just another hurdle on the path to progress? Do you believe satellite delays like this ultimately benefit or hinder global connectivity? Weigh in below. Do you agree these setbacks highlight the need for newer, more reliable launch systems? Or are they an overblown concern in an inherently risky field? Let's discuss in the comments.